Good morning. This is Siru, and today we are going to talk about the abalone weight dataset. It is a dataset aimed to predict the age of abalone, and so that the farmers don't have to do it manually, and we can speed up the picking process. And let's start. First, we import some libraries, of course, and then we import the dataset. And let's have a general look of the X. In total, we have 4,177 observations with 8 features. And we have a target value number of rings of the abalone. It is an indicator of the age of the abalone. And let's go to DDA. Um, First, we check the missing values and duplicate values. And fortunately, we don't have any missing value or duplicate value. So we don't have any more step in cleaning the data. And let's check the unique value of each features. And as we can see, there are three unique value in sex. So sex is a categorical variable. And we have other steps to preprocess it, and we'll talk about it later. And we combine the data sets to DF, and we use AutoVist function to visualize these variables. We can generate some two-way pair plots, so that we can see if there are any there are any possible relationship between any of these two variables. And as we can see, there are certain degree of positive relationship between these two variables. And also we can see the distribution of each variable, and we can see if it is normally distributed, the outliers of it. And we can also have a heat map to have a more direct look of the correlation of each two of these variables. And we can use the describe function to have a general information of the dataset. We can see the mean value, the standard deviation, and so on. And we check the skewness of the quantitative values in this dataset. And then we go to the preprocessing. First, we use label encoder to encode the sex into new numbers. We transform them into 0, 1, and 2. And personally, I don't think label encoder is a good way to encode the sex because there's no sequential order in gender. So maybe one hot encoding or dummy encoding is a better way. And we use two key rule to check the outliers in the number of rings, which is the target value. And we use the box plot to visualize it, the outliers. Um, and then we split the data into training set and data set. To be more specific, 80% of data we go to training set and 20% of them will go to the testing set. And we use the standard scalar to standardize the data set, the features, so that it can be normally distributed with the mean value equal to 0, and it can be scaled into between -1 and 1. And we use the random forest regressor to to see the importance of each features. And as we can see from the graph, shell weight have the most the greatest importance among all features, and then is shock weight, and also the whole weight and visceral weight are good predictors too. And in this case, we use MSE, MAE, and R-square as the metrics to evaluate the performance of the models, and we define a function to visualize the difference between actual values and predictions. And in this case, we use multiple linear regression, lasso regression, ridge regression, elastic neck regression, KNN, SVR, decision tree, and multi-layer perception as the models, and we set the parameters here. And we fit the model to the dataset, and we have the result. And the result is evaluated by the holdout validation uh, with the 20% of the testing set. And among all models, multiple linear regression is have the best in performance among all. As we can see, you have MSE equals to 5.1 and R square equal to 0.53. And specifically, we want to talk about the decision tree. And as we can see, the decision tree has a relevant lower bias. Its MSE equal to 8.67 and R square equal to 0.2. You can have a low bias but a high variance, so that you might have the risk of overfitting because it is a complicated model. And compared to multilinear regression, it has a high bias. It might have a high bias and a low variance, so you might have the risk of underfitting, and that's the trade-off between the variance and bias of a model. Uh, and There are certain reward application of this project. First, we can see from the feature importance graph. The feature importance shows that the shell weight is the best predictor of the abalone age, and it actually indicates that shell growth as a maturity marker of the abalone age, and farmers can prioritize monitoring shell weight to determine the optimal harvest time and to ensure the abalones reach marketable size while avoid the risk of overharvesting immature abalones. And also, whole weights and shocked weights are good predictors too. So these metrics reflect overall biomass and edible yield, and farmers can use them to estimate profitability per batch and streamline the grading process. And also, this project can also enable stakeholders to rapidly assess maturity levels of the abalones and to ensure abalones are harvested only when they are fully grown, and thereby promoting sustainability. Farmers and processors can benefit from reduced labor cost and improve volume. And regulators gain a standardized tool to enforce compliance with sustainability guidelines. And that's all of my presentations. Thank you so much for your time.